Hi, Sarah. Hi, Jorge.
Hello.
Sorry, hang on. Hello, Charlie. Can you hear me?
Hello. Yes, I can hear you now. Yep.
Perfect. Yes. Yeah, it was just playing with some configuration here.
Yeah, no, it's
Good.
on my side, I think, 'cause I'm traveling today. I'm in Madrid.
Traveling.
So different
Oh,
setup to usual.
okay. Where are you going?
In Madrid. So we've got an office in Madrid, and there's a new couple of team members joining. So I've come across to say hi.
Oh, cool.
Introduce them.
Cool. Interesting. Madrid. Oh, can speak Spanish there.
Sí, hablo español.
Sí, yo hablo español, claro. Yes. Oh, there is Sarah Nielsen. Hello.
Yeah, hey. I don't think we've met. It's my first participation here.
Oh, okay.
So
Okay.
I I thought I don't know if it's just the three of us, but I thought I would. I've started kind of discovering the IEC 43 and WeDoWind spaces, and I thought I would look kind of be an observer for today and see if this is something I want to be involved in.
Okay.
yeah,
Okay.
If it's
very
okay.
cool. So
Yeah,
yeah,
of
nice,
course.
nice to have you on the call. So it might be a fairly quiet call because I haven't advertised this one and I haven't really prepared anything for the meeting. But I'll give you all the context as to what this group is normally about, and then you've got the information. So I set up this group. I'm going to say 2 years ago now, or something like that, or longer ago. It must have been at least 3. After releasing some data from some operational assets that I had access to while I was working at Cubico. And then after releasing those data sets, I was like, well, this is great, but I actually want people to use these data sets to do analysis, to do research and development. And I had a chat with Sarah, and she was of similar view that, more data should be released. And once data is released, you want to get value from it. So have people use it. So yeah, I set up the group for that objective. And then within the group, the idea is to work on a challenge based on open data. So we've done an analysis of Kelmarsh and Pembrokeshire wind farms on what their long-term generation should be. So like an operational energy yield analysis. And then we've done a challenge on trying to identify the static yaw misalignment from turbines at Kelmarsh using the 10-minute SCADA data. We had a few results for that. The catch was there was no ground truth. So one person said, there's 0 error. Another said there's 5 degrees error. But we don't know what the the true error on these turbines was.
Yes.
So we tried to solve that by doing another very focused challenge, because one of the issues with the methodology for calculating static yaw misalignments is that it relies on nacelle anemometry traditionally. And so we were like, well, if we can remove that reliance on the nacelle anemometer, then we should be able to determine the static yaw misalignments.
Okay.
So what we did for that was we did a very focused challenge. It was, okay, can you predict the wind speed at a target turbine using only data from other turbines?
Sister turbines, correct.
So the idea being then you've got a fully independent measurement of the wind speed that you can then use to determine static yaw misalignments. So that challenge was run last year. And then we tried using the result from that earlier this year. And what we discovered was actually this supposedly independent measurement with the best performing models was not actually independent of the parameters on that individual turbine. Because there is an influence on the wind speed based on the yaw of a wind turbine. And actually from only using data at neighboring turbines, you can have a fairly good estimate of the yaw misalignment on that turbine. which means the wind speed estimate was like, well, to perform best to achieve that target variable, I'll account for the fact that I know there's this
a defect,
dependency.
a problem. Yeah, because your target, what you are mirroring the behavior of the error of the yaw misalignment. I mean, that's you're always looking at the power of the defect turbine, so to speak.
Yeah. So you're effectively using a target that is imperfect,
influenced,
and
it has the error.
Yeah,
it's a tricky. You need exactly the same condition, just a mirror of that turbine somehow, or maybe an extra anemometer, an extra, I don't know. Yeah.
So there's a few different ideas of how we can solve this, like just removing some of the information from the other turbines that can be used to infer the misalignment on the target turbine, or using simpler metrics that maybe can perform better. But we now have a new challenge coming very soon. Maybe not today, but maybe next month. Which will be using data from a test turbine at Ost University, Eastern Swiss Technology University.
Ost.
Yep. So they've got a test turbine where we've got data and we've applied known misalignments to the turbine.
Okay.
With an
To see the percentage of loss due to the yaw misalignment, or something like that. I mean, you have the ground truth.
We have the ground truth. Yeah.
Exactly.
So
and if you provoke a misalignment, how does that degrade the power production?
Yeah.
No?
So we know having a misalignment reduces the generation. What we want to do is be able to predict what that misalignment is, so we can correct for it on a industrial machine, so that you can gain back that like 0.5% or 1% of energy that you're losing.
Yes. Okay. Yeah.
Is there any link to your steering? With what you've been doing and looking at?
Yeah, so there is a connection to your steering, in that in fact, there's multiple opportunities here. With your steering, then you are applying a misalignment to the turbines, and you know what that misalignment is, and you will see a reduction in the performance of that machine. So you can almost use that as a way to validate a methodology for identifying static yaw misalignments if you've got that data available.
Okay. Other idea that it comes to my mind is to provoke like a disturbance. It means like just have a real turbine on site, okay? And let's say that you suspect that there is a yaw misalignment, and to provoke somehow some degree of like to track in a few degrees to see the change of power, to see a few degrees to see if there is an
improvement
power exactly something like that, very experimental, very
so
on-site.
Let me jump in right away to tell what kind of things we did on a wind turbine. So we do, so as Charlie said, we do have a wind turbine with that we are operating. We did force it to be misaligned. The important thing to note, and it's kind of like the wormhole we try not to get too much into, but it is important to know, and it's the asterisk I was saying before, is that we are not introducing a misalignment on the sensor. So it's not the sensor that is faulty, but here we are sending a signal through the controller saying certain angle is a zero angle, and it's so we can like forcibly.
You mean like calibration?
Kind of like a calibration
thing.
So we kind of can like force +4 degrees, +6 degrees, +9 degrees. where the sensor will have to have additional 4 degrees until it thinks it's aligned with the flow.
Yeah, it's an offset, a calibration offset.
It is not exactly. We were like thinking about it, and because of the influence of the rotor itself on the flow, it's not exactly the same thing if we would physically rotate the sensor. And to what degree and how, we don't really want to get into those rabbit holes, but it's just a thing we want to disclose right away.
Okay. Well, I mean, it would be nice, like, to take note of all these, like, possibilities, you know? I mean, we're talking about first, Charlie talked about an experimental setup, very lab approach, and now you're talking about a calibration.
So this one is the idea is that we operate at different calibration things. So we are forcing wind turbine. So we operate it at 0 degrees, which is supposed to be perfectly aligned, like no yaw offset. We don't know if the wind turbine is perfectly calibrated, so we don't know if 0 is a true 0 non-yaw misaligned wind turbine operating. So that is to start with, like, let's consider it just like 0 bias. And then, so we do have a lot of data from operating at that condition. And then we operated for like quite some time with 4 degrees, 6 degrees, and 9 degrees. I think at least 2 weeks, but some of them even more. Out of those 2 weeks, how many days are windy? I'm not be able to tell you right away. What we will do is we will provide the data as labeled. So labeled data telling you like, okay, this is all our SCADA information, power, like everything that we get from our.
So sorry, Yuri, you are from. I mean, you this data comes from your a company. What's your affiliation?
I'm work with Sarah.
Okay, you work with. Okay. Because I know. I mean, I know that here is common that we start to talk, but we don't know each other. But that because
sorry, I didn't.
Yeah. No, it's okay. It's very informal. You don't know me too, so it's okay.
So yeah, we will provide all the data labeled. So saying like, okay, this is all the SCADA data, and it is operating at 0 or 4 or 6. We will take out randomly 2 days out of each offset to use for validation and testing. And we will take out one data set. I think I don't remember which one we saw 6 degrees. I think. I think we will take out one of them. I don't remember right now which one we decided, but one offset will be taking out to test how good does the model generalize.
Okay.
So that whether it can predict. So to have a ground truth on a test data outside of that is completely unseen offset. To see just the generalization capability. We had some trouble. We had to start this month, but we are delaying it a bit because we had some trouble on getting data and formatting it and just time constraints. We might also have SCADA data from a nearby wind turbine that is operating, I think, at 0, like in a normal operation. It is owned by ATH. And that is why it's a bit more difficult to get the data because we don't have direct access to it, but we'll try to get it as well. And then the challenge will be the plan to set the challenge and to run it on this platform called Ranku, which is a computer the
data science platform.
Data science platform for reproducible code and computing. And if Florian, do you want to say a couple words about that?
So Ranku is this platform where we have you can connect different data sets with the GitHub repositories and then compute environment to get an easy start into this challenge. So it basically runs a Docker container, a pre-configured Docker container in the background. There is the OpenOA Python library already pre-installed on this one. It automatically downloads data sets from Zenodo. So our data set will be published on Zenodo and it automatically loads it into the environment. So we basically have a pre-built Python data set environment, and we can start right away with analyzing and testing some things. And the final goal is to, I mean, not to tell people what to use. So it's optional. You can use it, but you can also just do your normal local workflow if you want to. And we have a second repository, a public one, where you will be able to publish or submit your results, which is basically a simple CSV file. And then we do some behind the scenes testing on the holdout test set, and potentially what we actually have to talk about today with Charlie, if we want a leaderboard or not, where we can have like Kaggle style live leaderboards. So that's the idea.
Okay.
Okay, any questions, Sarah or Jorge, on that initial description? Ola, Eric, have you got some points as well?
I'm just processing the information. Yeah.
Yeah, that's cool. Okay.
But it's going to be an I mean the idea, of course, is going to be an open data set.
Yes.
Okay. Okay. And Florian, you talk about having just an environment, a Docker environment, just to be start and ready to analyze this data.
Renko uses that automatically, so you can link to a Docker environment which is loaded. They try to compute, and then but you could potentially also download this Docker environment if you want it locally and have it run there as well. I guess. So I think there are a few options how you could get started, either through the Renko environment where everything is done automatically for you, or you just clone a repository, or you even use the Docker container. Yeah.
Okay. And is there any date for this release? Is there any? I don't know.
Challenge release date will be next month. So whenever the next meeting is, I think it'll probably be the 15th of October, I think. I'll have to double check that, but yeah.
Okay.
And we'll do a bit of advertising before then to explain what the challenge is. There'll be a challenge description as well in the WeDoWind community area, so on Mighty Networks.
Yeah.
I mean, there's already a challenge description there, so you can have a quick look and see if it makes sense. And if you've got feedback, even better, feel free to comment.
And Charlie, if one doesn't have a possibility to participate in the challenge, do you plan to kind of present the results and methods to a broader community?
Yep. Yeah. So two ways that's happening. One is through these meetings. So you can join a meeting without actually participating in the challenge. Still, we encourage you to come with ideas. So people will present, hopefully, their results and their methodology for the calculations and what they've done. And it's always appreciated if people provide feedback to that person to say like, oh, this is really good, but I have a feeling that maybe if you did it like this, or if you looked at that, you might get an even better result. So you can very easily like participate in the challenge without actually doing the analysis yourself. And then the idea is at the end of the challenge, once we've got some results, then we'll present at a conference or write a paper to publish to the wider community.
Okay.
And again,
So
open to contributions for those as well.
So do you understand correctly that you're happy with people participating in meetings, but not analyzing directly, just to like share some experience? And
yeah, that's absolutely fine. So these groups are, well, one of the purposes of these groups is just to connect people and have people talking about topics that generally people are working on, analyzing SCADA data or doing some work in the field or on semantic models or similar, like where these things like all tie together. And so this is just an opportunity to kind of connect and discuss those topics.
Yeah, that's nice, because I was looking for such opportunities, and the thing is, I haven't presented myself. I'm a data analyst at wind owner and operator, so I'm sitting on a lot of data myself that I don't have enough time to analyze. So that doesn't seem like I can take the time for all the data sets than my own
analysis. You know what you could try. So this was one of my arguments at Cubico as well. When I released the data, I was like, so I'd come from a research background. I did a PhD in wind energy systems. Then I worked for a consultancy, and then I worked for an owner operator. And one of the arguments I took to management was like, we're sitting on all this data. It's got like potentially really good value if someone could analyze it. Okay, we've got some parties we're working with, but if we just release some of this data openly, then anyone can analyze it. And if they identify something useful, they can feed that back to us. And
you see the true potential. You see the true
Mm-hmm.
potential of the data and you filter.
Yeah. Eventually, data is not like gold. Gold goes up in value when it's sat in a vault. Data goes down in value with time. You're better off using that data and getting insights from that data rather than just saying, oh, we've got all this data, it's so useful and valuable, and we're keeping it all stuck in a closed room. This is one of the arguments for releasing data.
Of course.
Yeah, I totally hear that.
Yeah, and I do find it funny how you go from a data poor group which has lots of time to analyze but no access to a data rich group that actually has zero time to do analysis. So it's kind of a bit funny. So trying to connect those two groups is also very useful in my view. Yeah.
I'll see what I can do.
Yeah. I know if you want to have a chat just on open data and releasing data, happy to do that.
Sure.
So others in the WeDoWind group, because it's one of the key objectives of WeDoWind is to make more data openly available.
Yeah.
Okay, so that's the launch date next month for the challenge.
Okay.
In the meantime, I think it might be good, Eric, if you're on the line, just to give a quick description of OpenOA and the static yaw misalignment module that's available in OpenOA, so that this group is at least aware of that. And because it's set up as the kind of like base environment for analysis in Renku, or will be. Is that all right to put you on the spot, Eric?
Yeah, sure. That's fine. I don't have anything prepared right now, but like about the static yaw misalignment method. But OpenOA, yeah, it's a Python package, stands for Open Operational Assessment, and designed to assess the performance of an operating wind plant. So the main method is a long-term AEP estimation to estimate the long-term operational annual energy production based on some initial period of data, maybe 1 to 3 years of data, and then it applies a long-term correction using reanalysis or other wind resource data, and estimates what the long-term energy of that would be. And then it has some methods for estimating individual performance categories. So some examples are electrical losses in the wind plant or availability losses, something called turbine gross energy, which requires a little more explanation, but also a wake loss estimation method, and then yeah, kind of a separate category is this static yaw misalignment detection module, which is a really basic, very basic method that currently uses the wind speed from the turbine that you're trying to estimate the yaw misalignment on. So we know it has some issues. That's why hopefully it's a kind of a starting point to get some ideas for how to detect yaw misalignment. But I would say because of some of the issues Charlie mentioned, it might not be very reliable in all cases. So that method basically bins the power data, or bins the data of a wind turbine by wind speed. So you'll have maybe 1 meter per second wind speed bins, and then in each wind speed bin, it looks at the power as a function of the yaw misalignment of the turbine and applies some curve fit to try to find which yaw angle the turbine or the turbine's power is maximized at, and then treats that as the kind of the direction where the turbine is aligned with the wind. So if that peak occurs at a non-zero wind vane angle, then it will treat that as the static yaw misalignment. So yeah, it has some, of course, some issues. There can be biases in the wind speed measured on the nacelle that are yaw misalignment dependent. So yeah, treat that method with caution, but it is there as a starting point for some inspiration.
It's a good place to start. Exactly. Yeah.
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 Okay. Open ODE.
Open ODE.
So
oh yeah, thanks for sharing that link.
Yeah, I saw the link. You just shared the link.
Yeah, and I'll just give my view of Open ODE as well. So
okay.
Again, I've worked for a consultancy. I've worked for another owner operator. I'm now in a new company that also owns and operates assets. And one of the things you always find is when you switch company, you lose all the tools that you had in your previous company that have been developed over time because it's their IP. With something like Open ODE, I see a real advantage because it's open source. And if you use it, then it's constantly available to you if you switch company, and it's constantly available to the company that is using it at the moment. So for like operational energy yield analyses, in my previous job, I actually developed some in-house code to do those analyses.
Yeah.
In my current company, then the plan is to adopt Open ODE to do that analysis, not to create something in-house.
To create something in-house, exactly. New.
So to avoid that, and then if we see any issues with the way that Open ODE is doing the analysis, we can open an issue on GitHub where the code is stored and say, "Hey, Eric and team, we've spotted this problem in the analysis. It's doing this bit. We don't understand it, or it looks like it's doing it wrong in our view." And then there can be a response there. If the code needs updating or additional documents description or something like that, then it can be updated and changed. So I see a big advantage in that kind of methodology where something is an open source tool that people can contribute to. And for instance, it's quite modular. So the static yaw misalignment part is a piece to its own. The operational energy yield analysis is a piece to its own, effectively. Uses the same data model, uses the same setup. But if, for instance, someone's like, I've got this new bit of analysis that I want to do on wind farms, you can propose adding that to OpenOA, and if it kind of fits the remit, might need some modification to make it suitable for open sourcing. Sometimes in-house code and best practice don't always align. So this will force you into best practice. Then that can be like injected into the OpenOA library, and then it's available again for everyone to use. So I see it as a good kind of like industry project that can benefit everyone. It's kind of my 2 cents on it.
Yeah, and do you have you've made some valuable contributions to the code. Yeah, especially adding the examples that use the Cubico data, and some downloading functions for downloading reanalysis data. So that's a perfect example of what we're looking for in terms of contributions from the community, and really added a lot of value to the code base. So appreciate that, Charlie, your support of the code.
Yeah. Yep. Okay, so yeah, any questions on OpenOA? What's been discussed?
Yeah, I have to read
Oh, here maybe a small question. Does it include icing? We've been using task 19 method for icing. Did you implement that in OpenOA as well? Or we're in the Nordics.
Right. Yeah, we don't have that yet, but if there's an established method that uses readily available SCADA data, then I think that's something we could add. Well, I should say we'd be interested in adding that. Whether we have the resources to do that ourselves, I'm not sure, but I'd be interested in hearing more about that method and what it would take to implement that.
On that topic, we actually did release a data set from ATH wind turbine, which happened during the ice, where there was like an icing event that we know of. I think it was one of the previous challenges that we ran. So if you're interested in testing on that, I can also give you a link.
Yeah, I just wondered if it was, I think this package that sounds very interesting. I'm thinking about our own data and our own challenges, and would be keen to try it on our data. But I think we are in the Nordics, so we have icing. We have to take that into account. How long are the data sets you usually work with?
For OpenOA, yeah, I would say like 2 years is kind of the typical amount of data that we'll analyze. But there's no like upper limit on the length of the time series.
There are datasets that are being updated. So I read that one open dataset was they added new years with new sensors, with new channels, and more fun to load and to try to homogenize all the columns.
Yeah, correct. So recently there's been I don't think there's any icing on the Penman-Shiel or Kelmarsh datasets, or at least not a significant amount of icing, which are the two open Cubico datasets. There's also the Hill of Towie wind farm that was released recently by Res, And I think in that wind farm, then there will be some icing because it's like Scottish based, but I think
Yeah.
colder climate. It won't be to the level of the Nordics, and we've got some wind farms in Finland and Sweden as well, where icing is significant. But yeah, some open data sets that might have some icing data in.
Ah, there you go. This is the T19 ice loss method. Sarah shared
Yeah,
that
I
link.
share that. I can describe it
Yes.
quickly if you like. If not everybody is familiar with this.
No, I'm not.
Yeah, it was part of an IEA effort for like cold climate turbines where icing is a big problem. And you don't need to have any ice sensors, even though there is, I think, an option in the code to add an ice sensor, but you don't have to have it. And we typically don't have it, or not as a 10-minute series. And you work with 10-minute data. Status is, I think, 2. I think we've tweaked it a bit to use, to have other information about the turbine. But you basically use wind speed, power, temperature. That's the main 3. And you build an expected normal operation power curve for that you've been for temperatures over 2 degrees, where you know that you don't have any icing.
Okay.
And then you detect performance deviation compared to that reference power curve.
Yeah.
And,
you have a ground truth, a
classify.
base without
Sorry?
ice, normal operation. I mean, you have like a ground truth, a normal operation without icing. So you build a power curve, and then what? And then you have that, and you compare that to a power curve under a very low temperature.
Well, you look at the data set and you look at deviations at less than 2 degrees temperatures and classify that as icing event. And you have 3 different icing events. You have made like no production at all. The turbine is completely stopped because of icing. Usually the turbines cannot.
I see. A, B. That would be B.
Too much ice, so you cannot start.
Yeah. Okay.
After low wind events. And there's another category which is performance degradation.
Maybe.
And then the third category is anemometry icing, when you have ice on your sensors, which is usually quite low because in cold climate turbines you have heated sensors, so you usually don't have that problem much. So it gives you an idea of
okay. And this icing event class C.
I think class C is the sensor, right?
I mean, because it seems like a very, very high performant wind turbine there. Those data points.
Yeah, it looks like it's very high performance because the sensor is impacted, so it measures lower wind speeds than there actually is. So it looks like the turbine is overperforming, but it's not a real overperformance. It's the sensor that's impacted.
Oh, okay. What a lie.
But as I said, on cold climate turbines where the sensor is heated, you usually don't have that many points in class C.
Okay. Yeah. Ooh.
Yeah.
Oh, that's very interesting.
Yeah. Yuri's posted up, and a very good point. This could be a really good challenge for the future, where we get a data set and we try and determine the icing losses using this standard, and then we integrate this standard into OpenOA. That could be a very nice group project.
That would be a nice challenge, like to identify, okay, where are the icing events and classify them A, B, and C.
Yeah, and determine what the loss is.
Yes. Yeah. That's a nice machine learning.
We actually did that on all of our portfolio. We have more than 200 turbines. We did that on all of them. And we see the variation year to year is significant. But I'm interested in the rest of the losses. Now that I've determined the icing losses, I want to know about the other ones.
Which ones?
Well, you know, anything that can impact performance, like the static, like you were mentioning, static pure misalignment, there are other performance issues. I will look at what Open OA can do, see if I can find something interesting for our data sets, and then maybe I will see what we can do with that.
There was another. Sorry, Florian. Do you remember what's the name of a person who was doing research on where the wind sensor was not calibrated properly, and it was causing like quite a lot of loss on the wind turbine performance because of it was impacting the controller.
Davide Astolfi.
Yes, Davide Astolfi. Yeah, that's another interesting source of losses that we've seen. He published quite a lot on that.
What's it called? Sorry.
I will find it.
Davide Astolfi, I think.
I'll look it up.
And another project that I know TU Delft is starting is they're looking into optimizing controller for the pitching angles, because sometimes they don't like know perfectly well, or they assume there will be some certain angle of attack, but they're not actually like it's not perfect. So they're looking into optimizing the pitching controls. So they're just starting that research. It's like the whole 3 or 4 year project that is going to be researching that.
That sounds interesting. I was wondering about the wind sensors, because you said that you are using the wind speed quite a lot, but the wind speed is very uncertain. Like the wind speed measurement in the turbine is very bad. Well, I can say even when you have a good transfer function, you know that it's not. So how can you say, when you use that, how do you know that you get good results with it?
I mean,
yeah, I think it's like I see it like a reverse engineering problem. I mean, maybe power measurements are really good. With power measurements, you can reverse and get the wind speed somehow. I mean, yeah.
Yeah, you can do that. And actually, yeah, some manufacturers that do that, they have what they call wind speed estimators, and they don't only use power, but they use the pitching and the rotor speed to kind of, okay, that's what the turbine is doing right now, so the wind speed must be that. But we don't know if that's truth, you know. You assume that your turbine is performing perfectly, but we know it's not always the case.
Exactly.
So for instance,
really good, okay conditions. Exactly. That's a huge assumption.
Well, this is it. If there is a yaw misalignment or a pitch misalignment or something that's affecting the performance, that will just adjust your wind speed to make it look like performance is still perfect. It's the kind of catch.
This reverse approach, exactly, it would be like, yeah, the perfect S curve.
Yeah, perfect power curve. So there is actually a challenge running at the moment with RES and the Hill of Towie dataset, which is to predict the power at a turbine using data only from other turbines on the wind farm. And the idea here is that you can identify when performance changes have been made. So you've got your baseline expected power generation from that turbine, and then you see it change on a certain date because something's been done to the turbine. And actually, what I think is great about the Hill of Towie dataset is that there's known changes made to the turbines. So then you've got some dates where you know the turbine's performance has changed. And so the longer term objective is to see what is that performance change.
Yeah, Charlie, you know, I dedicate some hours to that data set, and I saw a potential degradation in, I mean, from this data set, we have from 2016 to 2020, okay? And I saw 2016 to 2019, 4 years of data pool, I think I caught a degradation, a small degradation in the last 2 years. Okay. I'm going to publish that tomorrow just to generate conversation. Okay. I usually publish things in LinkedIn, because it's nice to hear people from different parts talking about that. And I saw something interesting there. Did you see? I mean, in my last post, did you see that I cleaned the data using DBScan? You saw that, no?
Yep.
And yeah, with this clean data, I'm trying to, I did something with the Turbine 3, and I think you can catch, it is my opinion that you can catch some degradation using a very, very simple method, is smoothing splines. It's just because I'm participating in this Kaggle competition, although I have to submit like 7 times. I was trying really simple things, but I'm trying to come up with something really, really simple. No, I mean, I don't want to spend 8 hours optimizing hyperparameters. So I'm trying to do some, more statistical learning method, like splines and nonlinear, non-parametric methods and that stuff. But anyway, that's very interesting. Very interesting what I found, and maybe that's this potential to have how through the years how this power curve tends to shift to the right. Okay, so basically, yeah, that's the analysis. Very, 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 very simple. Once you clean properly the data, once you have your data of full performance, okay, well labeled data, no? So that's the advantage to have this point.
Yeah.
So,
and Jorge, if you want more feedback from a group of wind energy analyst type people,
yes,
a good place to post, and Yuri's raised this, is on the WeDoWind platform. So you can
on the WeDoWind, but the thing, the platform is that I don't know where to post
it. Yeah. So if you go to
because I did a bit chaotic. Maybe you can show me where can I where can we I mean, this would belong to the Hill of Towie dataset, or should I do it in general? That's what I don't know how to.
Yeah, so I can
I'm in the portal now. I'm in the portal
group, and you can post something in the feed. That's probably a good place for it because you're using the open data. I can't actually share my screen at the moment because the Wi-Fi seems to be blocking the website at the moment. Don't know if you're Florian, you can quickly navigate and share your screen.
Where is it? I'm here on WeDoWind, but you have general, we have collaborative problem solving community, information modeling community, open data and code community, and data users community. Where do you think is the ideal space?
So if you share your screen a second, I can navigate you to the right place.
Okay, I will show you. I will show my screen. Wait a minute. It's really a little bit chaotic here. Where share? Here, share. Okay.
Yeah.
I'm there. Look. Where should I go?
So you see the collaborative problem solving community on the left-hand side? In the navigation bar.
Collaborative problem solving community. Yes.
And we've got open data exploration as a group. So that's this group, these meetings.
Of course.
And you can post in the feed.
Feed. Okay. So ODE feed.
Yeah. And then this will post to
ordinal differential equations. Sorry, and ODE is no open data exploration.
Right.
Okay. Yeah. So ODE open data exploration and feed. All right. So there you go. And I can post images, give whatever I have. Okay, cool.
Yep. Yeah. And I think when you do the post, I'm not sure if it's just me, but when you do the post, I think it says, do you want to notify people? And you can click yes, and then it will.
I mean, if it is specific to Hill of Tally, maybe Hill of Tally feed.
Good point. Yep.
Yeah,
either
here
Yeah, that's the thing. That's the thing. Should I do in general for all the open data exploration, or should I focus on, okay, no, the data belongs to Hill of Towie. Let's post in the Hill of Towie data space. That's a good question.
I would just go with Hill of Towie data space, probably, because that's where
it's more relevant.
And
yeah.
Okay.
Okay. Just, yeah, post those thoughts here, and then much more likely people who are using this data will see it and will react to it and engage with it.
Perfect. I do it. I still have to arrange the dashboard, the plots, and I post it here too. Okay, perfect. Yeah, good idea. Good idea. Ooh. Okay.
Cool. Okay. So I think we've covered everything I wanted to cover in this call. So yeah, thank you all for joining. If you've got any more comments or questions, emojis.
Oh yeah, good. Look, there is
Where'd they
heart
come
there.
from?
How do I do that? React. Okay, cool. Not so familiar with Zoom interface, but
Yeah.
nice.
Yes.
No, Charlie, thanks for your time. Okay, this hour is something, and for sure we'll meet next week.
Next month. Yep. Yeah. And
we'll
do a post and a bit of advertising around the challenge, so you might see something on LinkedIn and on the community space as well.
Exactly. Good. I always look for networking. Network.
Yep.
Nice. Okay.
Right. Thank
Bye.
you.
Bye. Ciao. Have a nice day.
Goodbye.
Bye.
Bye.
Thanks.
Thanks.